This is a series circuit we will use to find the value of the current. Okay. To find the current, we will need to put the current probe here. We also can put the voltage probe here to measure the voltage and put the reference here. And then we will run the simulation. Okay, so here we can see that 12 volt with the 200 ohm resistance, we will get 60 milliampere for the current. Okay, we can also change the value to 9 and run the simulation again. Okay, so here we can see that the current is decreasing to 45 milliampere for the current. Okay, so here we can say that the relationship between the voltage and the current is the voltage is proportional to the current, where the higher the voltage is, the higher the current we will get. Okay. Now we will change the voltage to 5, and the value of resistance we will use 68 ohm. Okay, and we will run again. Okay, with 5 voltage and 68 ohm for resistance, we will get 73.529 milliampere. Okay, now we will change the value of the resistance to 100. And we will run again. Okay, so here we can see that the current is decreasing to 50 milliampere. Okay, so here we can say that the relationship between the current and the resistance is the resistance is inversely proportional to the current, where the higher the value of the resistance is, the lower the value of the current we will get. Okay.
Okay, this is the figure 1 that we need to build the circuit diagram. From the previous video, my partner Nabilah has shown that we need to construct a circuit by using the setup the circuit as shown in figure 1. So this is the circuit. So the number 4 is experiment and data and result. For experiment data and result, there's two table 1 and table 2. So this is the current intensity measured and current intensity theoretical that we need to calculate. So this is our measure and theoretical. And for number 5, question and discussion. Okay, let me start from number 1. From your data table, examine what happened to the current when the voltage was double, triple, quadruple, and so on. So the answer is the current increasing as the voltage increase. Number 2 is based on number 1. What type of relationship do you believe exists between voltage and current? And the answer is the current is directly proportional with the voltage. And for number 3, from your data table, examine what happened to the current when the resistance double. The current decreasing as the resistance increase. For number 4, based on the question number 3, what type of relationship do you believe exists between current and resistance? The answer is the current is inversely proportional with the resistance. So number 5, we are told to build a graph, to plot a graph of voltage versus current intensity for simulation and the theoretical result. Based on this table, we need to plot a table. So this is the graph that we have been plot. This is the voltage versus current intensity for table 1. This is voltage versus current intensity for table 2. And this is so we move to number 6. By using AZHA, plot a graph of current versus resistance for simulation theoretical result in table 2. So this is for the table 1 and this is for the table 2. This is for simulation graph, this is for theoretical graph. Okay, the last one is the conclusion that we have gained from this lab is, from this lab we are able to understand the relationship between voltage, current, intensity and resistance, because we build the circuit based on the figure 1, okay, so that we can understand the relationship between the voltage. Also, we also learn how to measure the voltage and the current on the circuit by using the probe in BINTI Live. Okay, that's all for lab 6. Thank you.